Mars, often referred to as the red planet due to its reddish appearance, is the fourth planet from the Sun in our solar system. It has captivated the imagination of scientists, astronomers, and the public alike for centuries. With its surface marked by vast deserts, enormous volcanoes, and deep valleys, Mars presents a fascinating and mysterious world that continues to be a prime target for exploration. As our closest neighboring planet with a similar length of day, polar ice caps, and seasonal changes, Mars has sparked widespread interest in the potential for future human habitation and exploration. Mars has a diameter of about 6,779 kilometers, making it roughly half the size of Earth. Despite its smaller size, it has a surface area that is about the same as Earth's dry land. The planet's gravity is about 38% of Earth's, which would make a person feel significantly lighter on Mars. The gravity on Mars is insufficient to retain a thick atmosphere, which contributes to its cold and arid conditions. Mars' atmosphere is primarily composed of carbon dioxide, 95.3%, with traces of nitrogen, argon, and oxygen, making it unsuitable for humans without the aid of life support systems. The planet's surface is covered in iron oxide, or rust, which gives it its characteristic red hue. This iron oxide has been formed over billions of years as a result of chemical reactions between the planet's minerals and the sparse amounts of oxygen in its atmosphere. The surface of Mars features a wide variety of geological features, including vast plains, deep canyons, ancient riverbeds, and enormous volcanoes. One of the most prominent features of the planet is Olympus Mons, the largest volcano in the solar system, standing at a towering height of 22 kilometers. This supervolcano is roughly 600 kilometers in diameter, far larger than any volcano on Earth. Mars is also home to Valles Marineris, an extensive canyon system that stretches over 4,000 kilometers across the planet's surface. This canyon system, which is one of the largest in the solar system, is up to 7 kilometers deep in places, making it one of the most striking geological features on Mars. The formation of such large-scale structures suggests a dynamic geological history, possibly involving tectonic activity in the distant past. However, Mars does not currently exhibit active tectonic plate movement, and the planet's crust is believed to be solid and largely unchanging. In addition to its impressive topography, Mars has two small moons, Phobos and Deimos. These moons are irregularly shaped and much smaller than Earth's moon. Phobos, the larger of the two, is slowly spiraling inward towards Mars and is expected to eventually crash into the planet or break apart, possibly forming a ring system. Deimos, on the other hand, is in a stable orbit and is slowly moving away from Mars. Both moons are thought to be captured asteroids, and their irregular shapes and craggy surfaces are evidence of their origins in the asteroid belt. Mars experiences seasons similar to Earth due to its axial tilt, which is only slightly less than Earth's tilt. The planet has a day length of 24.6 hours, making a Martian day almost identical to a day on Earth. However, the Martian year is much longer than Earth's, taking about 687 Earth days to complete one orbit around the Sun. As a result, Mars experiences longer seasons, with the southern hemisphere having a slightly shorter summer due to the planet's elliptical orbit. The seasonal changes on Mars are also marked by the growth and shrinking of polar ice caps, which consist primarily of water ice and carbon dioxide ice. During the Martian winter, the southern polar cap grows, while the northern polar cap shrinks. Conversely, during the Martian summer, the opposite occurs. The temperature on Mars is incredibly cold compared to Earth, with average surface temperatures around minus 60 degrees Celsius. The planet's thin atmosphere cannot retain heat, and the planet's surface experiences wide temperature fluctuations, ranging from a high of around 20 degrees Celsius at the equator during the daytime to a low of minus 125 degrees Celsius at the poles during the night. These extreme temperatures, combined with the low atmospheric pressure and high radiation levels from the Sun, make Mars a challenging environment for human exploration. One of the most significant aspects of Mars that has drawn scientific attention is the possibility that the planet may have once harbored life. Evidence from spacecraft missions and rovers on the surface suggests that Mars had liquid water on its surface in the distant past. Ancient river valleys, lake beds, and minerals that form in the presence of water have all been discovered on Mars, indicating that water played a crucial role in the planet's history. Mars's surface is also home to a variety of signs of past volcanic activity, which may have played a role in sustaining a more habitable environment. Scientists have hypothesized that Mars once had a thicker atmosphere, which could have allowed for a more temperate climate with liquid water. However, the planet's weak gravity and lack of a protective magnetic field allowed the atmosphere to slowly erode over time, and the planet's surface was exposed to harsh solar winds and radiation. This dramatic change in Mars' environment is one of the primary reasons why it is now a dry, barren world. But the question of whether microbial life may have once existed remains an area of ongoing investigation. The exploration of Mars has been a central goal of space agencies such as NASA and the European Space Agency, ESA, with numerous missions launched over the past several decades. These missions have provided a wealth of data about the Martian environment, geology, and atmosphere. The most famous of these missions include NASA's Mars rovers, such as Spirit, Opportunity, Curiosity, Perseverance, and the recent Ingenuity helicopter. These rovers have explored the Martian surface, conducting experiments and analyzing rock and soil samples to better understand the planet's history. The Perseverance rover, which landed on Mars in 2021, is part of NASA's ongoing efforts to explore the planet's potential for past or present life. It is equipped with advanced scientific instruments, including a drill that collects rock samples for future return to Earth, as well as a microphone that allows scientists to listen to the sounds of the Martian environment. Perseverance is also carrying out a joint mission with the Ingenuity helicopter, which is testing the feasibility of powered flight in Mars's thin atmosphere. In addition to NASA, other countries and private entities have shown interest in exploring Mars. The ESA, in collaboration with Roscosmos, launched the ExoMars program, which includes the Rosalind Franklin rover, aimed at searching for signs of life and understanding the planet's geology. Meanwhile, SpaceX, a private company founded by Elon Musk, has ambitious plans to send humans to Mars in the coming decades. SpaceX's Starship program aims to transport large numbers of people to Mars and establish a permanent human settlement, a bold vision that has captured the public's imagination. Mars's potential for future human colonization is a subject of intense debate and research. Scientists and engineers are exploring various technologies required to make such a mission possible, including life support systems, habitats, and transportation methods. Some researchers believe that the planet could be terraformed over centuries, making it more Earth-like by introducing greenhouse gases to warm the atmosphere and create conditions for liquid water. However, such an endeavor is fraught with technical, ethical, and environmental challenges. For the foreseeable future, any human presence on Mars will likely be limited to small scientific bases or exploratory missions. Despite the challenges, the idea of colonizing Mars raises intriguing questions about humanity's future and its relationship with space. Mars represents a potential backup for Earth, should our planet face existential threats such as asteroid impacts, climate change, or overpopulation. However, colonizing another planet also presents significant moral and logistical challenges, including the ethical implications of altering a foreign ecosystem, the costs of such ambitious projects, and the potential for unintended consequences. As our understanding of Mars deepens, so too does our appreciation of its role in the larger context of planetary science. Mars is a reminder of how much we still have to learn about the solar system and the processes that shape planets. It also underscores the importance of exploring other worlds, not only for the possibility of life beyond Earth, but also for the knowledge and technologies we can gain to help us address challenges on our own planet. In conclusion, Mars remains one of the most captivating and enigmatic planets in our solar system. Its striking appearance, geological diversity, and potential for past life continue to inspire scientific inquiry and public fascination. As technological advances make it increasingly feasible to explore Mars, the coming decades will likely see continued efforts to unlock its secrets and perhaps one day establish a human presence on the red planet. Whether or not humans ever call Mars home, the exploration of the planet promises to yield valuable insights into the nature of life, the history of our solar system, and the future of human exploration.